competition, and it was all for UK and Ireland installers and people that wanted to install a heat pump. And the idea was to install a Viessmann heat pump, an air source heat pump, and see who could achieve the highest efficiency over the year. So we entered the competition, and we were very fortunate that we were the winning entry from Ireland. So we're now competing against 14 other companies throughout the UK to see who could get the most efficient heat pump. That result will be sort of announced at the end of July. So we're not too sure where we're in the standings at the moment, but we're going well in the league table. So the idea was we had to put forward a good system design, and we picked a design and we looked at all the various aspects of it. And this design actually that we submitted was a good example of some of the core fundamentals that you gain whenever you come on the Ecoerne training. So we look at all the core aspects of how do you get a good installation, and how do you get to a stage where you've got a quality, really efficient installation. So as I say, we've submitted the design and we were very successful in achieving that. And I suppose the unique situation that I had was, yes, we had the design. I was fortunate that I had the option that I could pick some of the graduates from the actual training. And lo and behold, we're so lucky to have them. Two of the graduates are here in the talk today. So Lee and Alex from LA Plumbing were very kind to be pinpointed as the installers up for all the aspect. And we also had another guy called Terry Harvey, and we'll talk about Terry Harvey, and we'll talk about his aspect later on. So the project overview, which project did we use? We used a property, it was a 325 metres squared property, a 5-bedroom property. That's 3,500 square foot. A property based in Fermanagh, and it was built in 2015. So not a relatively new building, but 10-year-old building. The actual building itself had previously been heated by a 32 kilowatt ETA wood pellet boiler. It was using approximately 4.5 tons of wood pellets per annum. This is working out around £1,350 per year. You can see an example of the actual installation here. We have the wood pellet boiler, a very, very good wood pellet, Austrian wood pellet boiler, all automated, very good quality. And you can see some of the quality workmanship here as well. We had our biomass pipe work coming into a low loss header, and then going into pump groups, one for the hot water and one for the actual underfloor heating manifolds. So again, everything fine, everything good, and to be replaced out with our heat pump and see if we can actually make it any simpler. The house itself also had a twin new air mechanical heat recovery system. So air tightness, everything was pretty good. We had good ventilation in the house, so we had a good basis to work with from a heat pump point of view, and we had a good level of insulation throughout the house. Not exceptional, not passive standard, but a good level of low energy insulation level. And we were fortunate that there was underfloor heating throughout, ground and first floors, all underfloor heating, and we had tile rads in the bathroom and en suites. And again, fortunate, we had a 300 litre unvented cylinder, high gain, heat pump ready cylinder, so no requirement to change the cylinder out to run with the heat pump. Now, what were the technical issues that was being experienced with this particular existing installation? The wood pellet boiler obviously was oversized for the building heat loss. It was running inefficiently. It was using probably more than needed of wood pellets. The existing tile radiators were undersized and not suitable really for low temperature heating. Anybody will know tile rads are the scourge of any plumber, because they don't even dry tiles unless they're piping hot. So to run them with the air source heat pumps is a bit of a challenge. And again, we'll cover that aspect later on. The existing primary pipework was again probably oversized. It was a lot bigger than that needs to be. And the existing underfloor loop design, we had no knowledge of the design. It was there. Nobody didn't know what loops was there, didn't know what length the loops. No information on the actual design aspect of it. The heating system controls were very complicated. They were difficult to use and not really user-friendly for any homeowner. And again, not something you really want in your heating system. The system water quality, again, was very, very poor. The manifolds, the flow centers, all brown water, black water. Again, something very familiar with when we see all our manifolds, really, really dirty water in them. And again, signs of leaks, actuators failing, leakage around the manifolds, leading to the point where probably all the manifolds need total replacement. So again, poor water quality leading to these sort of defects in the manifold system. So what did we want to achieve from this? What was our objectives? So basically we wanted less reliance on the biomass, the wood pellets. Obviously wood pellets, the price has increased. It's now over £300 a tonne for wood pellets. The maintenance costs, again, Austrian wood pellet boilers are very, very expensive. The parts are extortionate. It's a very, very hard unit to run, especially with the demise of the RHI. It's very, very expensive product and very, very expensive to run it. The heating system, we wanted it to be as simple, and we wanted to make sure that it was able to maintain nice comfort levels throughout the year, stay at a steady rate, no high fluctuations in temperature. We wanted it just to stay nice and comfort level throughout the year. The system must be capable of being remotely monitored, so we want to be able to access how it's working efficiently, is it, and what's the performance of the heat pump. So this was another sort of a red line for us, that we had to have that sort of remote monitoring in place. And obviously on site, it had to be able to utilise the existing My Energy ecosystem. So there was 20 kilowatts of battery storage on site and 4 kilowatts of a solar PV array. And again, we were going to use these to our advantage to try and minimise the cost of electricity for running the actual heat pump itself. And obviously, probably most importantly, we wanted to reduce the building's carbon footprint. I know that's probably not on every plumber's top list, but unfortunately, that's the added bonus that we wanted to achieve as well. So, where do we start? Well, obviously, when we start with the design, and it doesn't matter what heat pump you're fitting or what you're fitting, as long as the first thing you have to remember is heat loss, heat loss, heat loss. We have to start off with the heat loss. If we don't know what the heat loss of a property is, then we can't even start the design process. So every job and any project that you're involved in, we need to know what the heat loss of that building is. Once we know the heat loss of the building, then that's our starting point for design. Now, in the likes of our case, we use heat engineer software for doing our room by room heat loss analysis, and basically we can go through all the rooms. We take into consideration the fabric, the U values of the materials. We take into consideration the air changes. We combine all that all together, and then that leads us to enable a decision on, right, what's the actual heat loss of this building. On our particular case, the actual building total heat loss came out at 6.77 kilowatts at minus 1.64 design outside temperature. So what does that actually mean? So that actually means when it's minus 1.64 degrees outside, this house loses 6.77 kilowatts. So therefore, we have to add 6.77 kilowatts to this house when it's at that design outside temperature. Now, bear in mind, we have a 32 kilowatt pellet boiler that was providing that heat. So the 32 kilowatt pellet boiler only needed to provide 6.77 when it was minus 1.64. So highlighting it's oversized, but most properties you will go to, you won't be able to buy an oil boiler or a gas boiler less than 15 kilowatts is probably the smallest on the market. So all boilers, all are oversized. In our case, we're fortunate we were able to size it according to the actual heat loss itself. So we've established what the heat loss is, so our design process can now start. We can actually now start looking at how we're going to design this system. Next issue we obviously had is, well, we can't design, we have a retrofit system, so how do we know what to design if we don't know what's in the ground, if we don't know the size of our emitters? So we used our Testo 868 thermal imaging camera to try and establish what are the pipe spacings, what's on the ground, what's the pattern, what's our loop lengths, and this This was very useful to understand what's on the ground, what are the pipe spaces, are they suitable for low temperature heat, can we design our flow temperature. So again, with the thermal imaging camera, this gave us a good insight to what was actually there and the size of the emitters. We then actually took all that heat loss assessment data, so all the information that we have taken, we actually used a piece of software called H2X. Anybody that's familiar with software, H2X is very much designed for system design. So all the information that we have received from our heat loss calculation, our underfloor heating pipe work, we were able to input this into our H2X software. And what that enabled us to do is it made that the design that we were able to come up with ensure that we had the correct pipe sizing, we had the existing underfloor heating pipes were going to be adequate, and the floor coverings were going to be adequate to provide the desired room temperature to heat this property to 21 degrees throughout. The software also is very useful for us to understand which was the index circuit, the most restrictive circuit of the system, to ensure that our heat pump would have the adequate level of pump head left, so that we would make sure that we could actually pump to all the actual underfloor heating loops, so that there was nowhere that was going to get starved, and our pump was actually going to be adequate to do the job. So the installation itself, obviously it was a Viessmann competition, and we installed the Viessmann Vitocal 150A heat pump. Obviously we chose an 8 kilowatt. We chose the 8 kilowatt not because it's an 8 kilowatt. The actual 8 kilowatt produces 6.8 kilowatts when it's -7 degrees outside. So we knew the 8 kilowatt was the correct size because we only needed 6.7 at -1.64. So the 8 kilowatt was our correct choice. Our friends and esteemed colleagues down in Precision Heating will be able to give you a lot more technical detail than me, but the 150A, as a slight overview, it does outputs right from 4 right up to 16 kilowatt. It is a monoblock air source heat pump, so there's no requirement for an F-gas engineer. It uses R290 refrigerant. This is a very green natural refrigerant, and it's got a GWP of 0.2. Probably one of the most valuable assets to the Viessmann heat pump is actually the built-in 16-litre buffer or volumizer that is there for the defrost. So this feature is a patented feature with the system, so whenever it comes to defrost in the cold weather, whenever it's down around 0 degrees and below, the actual system, the heat pump doesn't take any heat from the system. It actually takes the heat from this volumizer, this 16-litre volumizer. So you have whenever it's defrost, it's actually not taking any heat from your system. It's actually using the volumizer. Other manufacturers really struggled over that cold snap that we had before Christmas, because they were actually taking the heat from the system and then they were having to play catch up. And again, we haven't had a cold snap like that for quite a while, and I tested a lot of the heat pumps, but again, the Viessmann had no issues whatsoever, and I'd say this patented feature. Another patented feature is the hydro auto control. This maintains the flow rate at all times, and again, a really good feature, and I suppose a nice interactive 7-inch colour touchscreen display, and again, the unit itself very user friendly, very easy to use for homeowner and installer. The design we were obviously going with, it was full weather compensation and all open loop design, so no actuators on our manifolds, no room temperature, no thermostats controlling any. It was all open loop, one big full open loop, and again to maximise the efficiency and all running at full weather compensation. And I say to optimise and maximise your efficiency, these are the best features for achieving that. We removed all the existing tile radiators, and we've replaced them with electric, thermostatically controlled ones. Anybody who knows about tile radiators will realise that this is probably the best thing that you can do, because again, that is exactly what they are. They're only tile radiators. They don't provide much heat to a bathroom or ensuite. So again, this was going to cause a lot of problems by running a low temperature system to try and get heat out of radiators, tile radiators. In most cases, they're an aesthetic feature in a bathroom nowadays. They don't provide enough heat to heat it. We also installed the open energy monitoring kit. This is installed to give the installer and the homeowner a sort of an in-depth look at the heat pump's performance and notice any efficiency or any trends in how the system's working. We'll come back to the open energy monitoring and I'll explain it in a wee bit more detail. And finally, we installed a magnetic water treatment system, and we wanted to include VDI quality standard water. And what that is, that's basically a chemical-free water treatment system. So no chemicals, no inhibitors, nothing in your water, just pure demineralized water. And again, we'll touch upon that in a few slides to come. So what were the challenges with the installation? And the guys here will probably, they'll know these too well because they had to sort a lot of these issues. So challenge one was actually the siting of the external unit, the actual Viessmann Vitocal. So firstly we had R290 is a propane gas, and basically it has a safety zone around the heat pump. So we can't put any electrical isolators within the safety zone. We can't have any windows or door openings in the safety zone. So we had to choose very wisely. The second issue that we had, it was going on to paving. The client didn't want to cut any of the paving. They had just recently installed it. They didn't want any damage done to it. So we had to come up with a solution of, rather than creating a concrete plinth, we had to do something that was going to be decorative or acceptable to the client. So the solution was, we were at the installer show in Birmingham last year, and Ecoerne Renewables had on display these Zeus articulated mounting feet. So these are a very innovative product, and they were the ideal solution to overcome uneven surfaces. And in our case, we had a bi-directional flow. We had a fall coming this way, and we had actually a fall coming from right to left. And again, you can see from the picture, we have the feet, and they're at different heights, but we've been able to maintain the levelness. So again, a perfect solution, and no cutting, no change of the paving, everything in situ, and it worked really, really well, and they are very, very good, stable product. Challenge number two, we wanted high quality, waterproof, UV proof external insulation. I've just read an article this morning